Hello and welcome to Great Learning. I am Neha Kaplish and I'll be moderating your session today. Today's masterclass is being taken by Professor Nirmallya Mukherjee, and the topic of the discussion is about cloud computing. So I have the honor of introducing Sir today. With 2.5 decades of cross domain experience in IT and ITES across both services and products, Professor Nirmallya Mukherjee has served as Chief Architect at Dell, Principal Architect at Infosys, and Technical Architect at Ciber Inc. He lends his experience and expertise to various multinationals like Cisco, Walmart Labs, Amadeus, Mercedes Benz, ANZ, and Societe Generale, etc. through his consulting. So he also works and he also consults in development and training engagements. Professor Nirmalya is also the academic director for the graduate certificates in cloud computing programs. I welcome you, sir. I thank you for your time today. And the flow of the session is going to be like Sir will be talking and will be explaining about the topic for the better part of the hour. And then in the end, we'll be taking the questions. I'll be reading out the questions to Sir and he'll be answering them. So without further ado, I request Sir to take over and start the session.
Thank you very much, Neha, for that wonderful introduction. All right, let me share my screen. There you go. Okay, so the topic of discussion today is cloud computing. And to be honest, it's probably one of the most talked about subjects these days, isn't it? So I want to take you down in the memory lane for a little while before we come back to the present. So let's get started. 1950s, you know, that era where computers were unheard of. And that was the era where you had mainframes, big monster machines, huge capacity in terms of memory, compute, and in general, its capability to crunch large numbers for long periods of time. Very expensive machines. So very few enterprises in the world could afford that kind of compute infrastructure. So then came, probably within a decade or so, enterprises started figuring out, hey, we got a cheaper option than that. We can't, dole out $1 million for a machine, and unless we have really the use case that does justice, isn't it? So then came the era of mini computing. So it's kind of like a mini version of the whole thing. Not really exactly mini version, but you get it, right? Something smaller with lesser capability, lesser capacity, and it was far more affordable than the mainframes. So that existed for quite some time. And during this time, lots of programming languages, started getting built. And this was really the golden era of the Dennis Ritchies of the world, right? Who are the who's who, the father of modern computing in some sense, isn't it? And then came the 1980s, where IBM compatible. I don't know if you guys have heard of that term, right? There used to be these little standalone desktop machines with a green terminal, and they used to have floppy drives. By the way, just to let you know, those machines back in the 1989, when I wrote my first code in BASIC, did not even have a hard disk. Now, can you imagine what kind of machines those were? 640 kilobytes of RAM. But hey, C worked great on those machines. So if you really look at it, and if I want to now fast forward from the 1980s to say the 2000s, where compute gotten really, really cheap, you could get laptops really easy, you could get servers really easy, and quite economical, if I may add. So what has happened is, all this while, large enterprises, startups, any business in general has made significant investments in procuring these hardware devices, build applications over a period of time, all to support their business, right? So if I want to fast forward now to, let's say, 2015, so just 5 years earlier, So majority of the large enterprises have huge data centers, millions of dollars of investments, lots and lots of machines, storage, networking, and more importantly, some of these large organizations had data centers around the globe. You can imagine the cost of maintaining those, isn't it? So there comes a particular point in time where the enterprise essentially begins to think, okay, what am I doing? I am a manufacturer of potato chips. I am a manufacturer of aircraft engines. Let's say I'm a manufacturer of soap. And here I am, instead of investing my bottom line dollars or whatever currency, right, into investing, growing my business, figuring out where that next flavor is going to come, which will sweep the market off its feet. How do I make my aircraft engines more safer, faster, economical? And here I am spending money in my IT infrastructure. So there comes a point where the businesses started to wonder that, hey, you know what? Can there be an alternative? Is it possible that someone else with certain expertise can come in, can step in and say that, listen, I got your back covered. You focus on making the aircraft engine safe. I got your back for the data center operations. You make sure you build or you come out with the next flavor of the potato chips, right? And I got your back covered when you talk about infrastructure. So that was the time, and I think this was around 2008, I guess. That was the time when infrastructure as a service, platform as a service, and software as a service as a term was coined. So the whole idea was a third party would come in and give these as a service to the enterprise. And the players are infrastructure guys who basically come and say, oh, you need a VM? I got it for you. Right, you don't have to buy. You can rent it from us. You want to have applications? You want us to give you the entire environment in which your application runs while we take care of all the hardware, the backup, and everything else? You give us the application? Well, we got it done. That's platform. Software as a service, or very fondly called as business process. Why? Because it's not just, a single application per se, right? It could be an application which is fairly complex, right? And it also not, from the whole complexity side of things, it could be just an API. For example, I want to make an API integration with some third party to make sure that all the invoices information goes into that third party applications for taking care of all my financial accounting needs, right? So it can range anywhere, right? From a very complex application to an API integration. Now the business is getting happy. I said, all right, awesome, right? I got all of these service providers who are willing to take responsibility of my IT infrastructure so that I can really focus on what's important for me, for my business, which is making sure that the next generation aircraft engines is that much better. And furthermore, the whole idea of cloud computing, folks, you must listen to this really carefully, is pay as you go. So the idea of the cloud computing as an offering is there is nothing to buy. There's absolutely nothing to buy. There is no commitment. What you need to do is you end up using this much and you get charged for this much. It's never more, never less. If you don't end up using it, there's no charge. And that's a significant benefit for businesses for several reasons. And I'm going to come to that in a little bit. Right. From the cost perspective, it's really, really beneficial to the businesses. The reason because they do not have to make any upfront investments, which is also called as capital expenditure, CapEx. The real definition of CapEx is, I'll give you an example. Suppose you want to buy a car or a bike or something, right? You'll have to basically pay the vendor and then you get, the car. So that money that you pay to the vendor or to the, car manufacturer, right? That's called as the capital expenditure. The fuel that you put in the vehicle, that's also called as the running cost, the insurance that you pay. That is called as operational expenditure. So what basically happens is cloud computing, because it's no buy, just renting, you have now converted your capital expenditure into pure operational expenditure. And it's just common sense to figure things out. How is that? So if you don't run your car, it doesn't consume fuel. So if you don't run your application, it doesn't consume resources. So the fixed cost that the enterprises used to have in the past, now all of a sudden that disappeared, or rather that reduced significantly, and the enterprises got really excited by that. But there was a problem. While all of this on paper on concept really looks awesome, it's important for us to understand, well, how do I adopt this? How do I implement this? How do I make sure that the implementation journey is indeed successful? Do I know all the moving parts? Do I know the entire complexity of implementation? Well, as I said, if the business is not into IT, chances are they don't. And that's exactly where systems integrators kicked in. So they help the enterprises to adopt cloud computing, to move applications from on-prem to the cloud, to build cloud native applications. Some of these terms you must have heard. I'm just trying to put a context around it. Many a times it's actually said that, hey, listen, cloud computing is the solution to everything. Cloud computing is good, that it works. Well, maybe, may not be. To be very honest, there are use cases which are not designed for cloud. There are applications which are better off running in your own servers, in your own data centers. It could be security. It could be a legacy application which cannot be migrated over to the cloud. There can be many reasons. But net, one thing is for sure. Just like how you consume electricity without having to worry about how that electricity is created by splitting an atom or burning fossil fuel, right? Doesn't matter to you. You switch on the light, you pay for it. You switch off the light, you don't pay for it. That's exactly what has come to in terms of compute. And this was a significant benefit for the businesses. And suddenly they realized, oh, I don't have to make those gigantic data centers. I don't have to go out there and procure machines. I can get it on the fly. So now the question really is, while all that is great, let's actually look at another aspect. We already talked about the cost. I want to quantify that. So this is just on the lighter side, I wrote that. Do you think enterprises will take cloud just because Python, Java, C++, whatever your favorite programming language is, that looks nice on the cloud? Or it's a business decision, right? Whereby if you look at the formula, what does it say? You basically have the left-hand side and the right-hand side. The left-hand side essentially says, you've got the user hours, that is your application running to serve customer traffic. And you've got the revenue minus cost. Revenue is something the customers pays you, and the cost is something that you incur to run your data center. That's the left-hand side. The right-hand side, if I took the same application and if I deployed it onto the cloud, please note that when the application is not being used, it can actually idle. In other words, there can be so many servers serving traffic during peak hours, and during off-peak hours, I can let go many servers. Application servers is what I'm talking about. So my entire cluster size, the number of servers that are running for me, can vary during the day, depending on the load. And if that is the case, then obviously right-hand side will definitely look better. The only way the left-hand side, which is the data center, can at best become equal to the right-hand side is if utilization is the best. I'm sorry, I think I got it the other way around. Doesn't matter, you got the idea, right? So the data center can actually be equal to the cloud if the data center's utilization is 1, which probably will never be the case. I mean, where have you heard that the application is running at 100% capacity? CPU is at 100% capacity, memory 100% utilized, disk 100% utilized, network 100% utilized. That's not going to happen. So if your data center can never be 100% utilized, it can probably never match up with the cloud. And that's a significant benefit. I want to now talk about how these cloud services are offered. What are the different buckets? What are the different categorizations that a cloud offering can actually give you? Let's take a look at the left-hand most, on-prem. So when you're talking about an application, what you basically have is you've got to look at networking all the way till applications, right, to handle yourself in your own data center. At the end of the day, you're responsible. It's your data center. You've got to do everything. That's right from, to be honest, like, the diesel generators to the, backup network connectivity to the internet, everything. You're responsible for it end to end. Now, the point is, if I want to take this stack and if I want to apply that to the cloud and I want to superimpose infrastructure as a service, then what do I get? I essentially get this view where a third party, for example, Amazon, for instance, Google, for instance, Microsoft, these guys comes along and says, hey, listen, the hardware part, the networking part, the physical data center part, I got that for you. If you want to deploy your application, you can take a machine from us. It could be a virtual machine. It could be an unvirtualized machine. Doesn't really matter. I got your back. So if you see, the total number of steps necessary to host an application pretty much remains the same. What changes is some part of it is owned by a third party, and that it offers as a service. Because it is infrastructure, it's called infrastructure as a service. And if I want to extend this and say that, listen, I have an application. That application could be written in Java, it could be written in Python, anything, doesn't really matter. I am not interested in managing the hardware, not interested in managing the networking, the storage, the backup, recovery, patching, nothing of that. Nature, I am interested in taking care. Then what do I get? I get platform as a service. So again, the cloud provider has a different offering, platform as a service, whereby it says, that's fine. If you're not interested in managing the .NET environment or the Java environment or the Python environment, I got it for you. Give me your application and I will give you an environment where you can run all of that. And I take responsibility of it, including the scale. When I say scale, I mean adding more components when the load goes up and removing components when the load reduces. Elasticity. Elasticity is another subject, another discussion for another day. This is what it was 10 years ago. In the last 10 years, platform as a service has evolved. It has morphed into two more services. We very fondly call that container as a service and function as a service. This never was existing quite some time back, 10 years back easy. The difference is, and this is a very subtle difference, is in the runtime. So when you're talking about pure play platform as a service runtime, you're essentially getting, let's say, a Java runtime, a .NET runtime, a Python runtime, and then you take your application the way you like. Java application could be bundled the way it is, Python the way it is, .NET the way it is, or any programming language, the way it is, and you just simply drop it in that particular environment and it just runs. That's pure platform as a service. Containers. I'm sure you would have heard of that. Containerization. So containerization essentially says, or container as a service essentially says, you know what? I don't care what programming language it is. I don't really care what that application is. I want you to bundle the application in a specific way. And if you do that, I don't care, right, what environment you need. You give me that bundle. And that bundle is nothing but Docker image. You must have heard of the term Docker. Containerization, one of the tools for it, doesn't matter. Just think of it like this. You bundle your application in a specific way, and the container as a service provider takes that bundle and does whatever it does, just like normal platform as a service. Why don't I crank it even further? I now say that, listen, I'm not even interested in bundling the application, right? Hey, laziness is kicking in. I don't even want to bundle my application. I am a developer. I am writing code. You take care of everything else. So what I'm going to do is I'm going to give you the code and you make sure everything is in place to make sure that code runs. I'm now talking about functions, function as a service. But notice the terms: platform as a service, container as a service, function as a service. The last one does not say application. It says function, means small units of work. What's a small unit of work? Simple example: given a customer ID, give me the last orders this customer has placed. Function. Given an order ID, tell me what the fulfillment flow is. Has that order been delivered, yes or not? Give me the customer ID, tell me the balance in the customer's account. These are examples which are small units of work that you can host. So now all of a sudden you're thinking, oh, that's cool. So that means if I want to try out a new functionality in my application, all I have to do is write the function and deploy that. Absolutely. You know what? In early 2000s, we used to follow a process which was called waterfall. Okay, where we used to collect all the requirements, do the gathering, the design, and build the application over a period of time. And then the customer used to see whatever that application was built. Over the years, right, we have gone into agile development. Now tell me one thing, isn't this an awesome tool for your agile development? You can quickly put together a function and try it out without you having to worry about procuring hardware and all the other data center related dependencies. Isn't that awesome? Actually, when I was making this particular flow, I thought of a friend of mine. He basically said, in development, we are agile. After deployment, we are fragile, right? So let's not worry about the fragile part. But even if, hey, we all know when we write software, there will be bugs, right? We all know that. Yes, it doesn't matter what kind of testing we do. There'll be something or the other that will go wrong exactly at the wrong time. Just when the customer walks in and said, hey, I want to give you a demonstration, right? And you click on something and it doesn't work. It happens. Now, imagine there is an important customer and you have deployed a change and something does go wrong. If you went with the traditional approach of updating the servers, isn't it a sticky situation? Isn't it something, right, which gets you in a position, how do I roll back now? The customer is right there. You know, with these container as a service, function as a service, and to a certain extent, platform as a service, more so in function as a service, you can switch from one version to the other in a heartbeat. So if something does go wrong, and if you do have an earlier version which is functioning, you can switch just like that. So yes, so the fragile nature of deployment, right, can actually have a solution. And these are really awesome features that the business would really love. And finally, right, software as a service, or I would like to also call it API as a service. You can have a RESTful services call from some other service provider. For example, LinkedIn, you are integrating OAuth, right? Isn't that an API as a service? Does it have a face? No, it doesn't. You are integrating with, let's say, user voice. These are some of the services I have worked with, right? There's a little pop-up that comes in and said, rate us, right? Things like that. And it can be as complex as you're watching YouTube now, right? Do you care what programming language it's written in? Do you care what servers it's running on? What kind of storage it has? Nothing. Software as a service. So the range can be anything. One very important aspect, I really have to talk to you guys about this now. You see, when you take full control, You have the full flexibility to change vendors because you control everything from ground up. You can switch from, let's say, hardware manufacturer A to hardware manufacturer B. You can do that because you take control of the entire ground up, right from ground all the way to the top. If you notice very carefully, the moment I start using these function as a service, right, software as a service, more towards the right hand side, don't you think our lock-in increases? Agreed. It helps us in terms of ensuring that I do not fall into a trap of bad software going out, or I'm not able to roll back. I'm quickly able to try things out. All of those things, isn't it? I get that on the right hand side, but not on the left. So it's basically give and take. So you must have heard of a term called cloud native applications. Cloud native applications take advantage of more towards the right hand side. On-prem applications are more towards the left hand side. And none of the businesses would basically want to lose the flexibility, and none of the business, right, wants to lose the agility that you get on the right hand side. So guess what? The innovation is happening right in the middle. And that's exactly why what used to be just one tower, platform as a service, has now split into container as a service and function as a service. So it's basically the idea of the cloud is to give the businesses options. If you don't want to go complete cloud native, you have a choice. You can still stick with your application, bundle it the way you want, make an image, and I will manage that for you in terms of scaling, etc. If you want cloud native, that's fine too. So depending on the enterprise, every organization is different. Every organization will make their own call. Every organization's strategy is different. So you might find yourself in an organization that says that, yeah, all our applications are cloud native. Whereas another organization basically says, no, we like to manage everything. We are just leveraging certain components of the cloud. Does it mean the first organization is better off than the second? Absolutely not. It's an organization specific strategy. So we cannot have a global rule saying that when you want to adopt cloud computing, the steps are A, B, and C. It could be 1, 2, and 3. It could be A1, C1, D2. It could be anything. Doesn't really matter. So where are all these services coming from? What is this cloud thing about? Is it actually on the cloud? No, cloud is very much on the ground. These are some pictures freely available from the internet, right, of some of the data centers. These are the data centers that are actually powering cloud computing. These are massive data centers with lots and lots of compute, storage, networking, cooling towers, physical facility, right, and all over the world. When you're talking about some of the most popular cloud providers, such as AWS, such as Microsoft Azure, such as Google Cloud Platform, IBM, Oracle, all of these guys provide cloud services basically coming out of data centers that look like this. Just think of it like this. Instead of the businesses managing the data centers, these organizations are doing that on your behalf, on behalf of these organizations. And the best part is, and I want to throw this particular term at you, SDDC. What does that mean? Software defined data center. This basically means that using software, it could be scripts, it could be programming language, doesn't really matter. Using these, I have the ability to grab infrastructure components from the cloud. Infrastructure as code, IaaC, maybe another term that you would have heard. What that basically means is I can actually write a script or a Python code which can actually create a virtual machine on the cloud, can launch a database on the cloud, can deploy my application on the cloud. And these kind of capabilities are just absolutely rock star awesome for any business. The reason because And the one and the foremost reason is they don't have these things to manage, right? They can rent it at any point in time. Please don't forget the word rent. There is no buying. Imagine if you build all of this and there is no utilization. You don't have any users. Something that you were planning to do did not work. So while you are working on something else to launch the next version of the product, what will these servers do? Big question mark. Any enterprise, I'm just trying to think, any enterprise, if you really look at it, especially the software landscape, that software landscape is not just a few applications, a few set of servers. It's not. It comprises of many applications ranging from databases to application servers to CRM applications to ERP products, warehousing products, middleware, so many things. And historically, these applications were procured, these servers were procured by the enterprise to host them in their own data centers. So one thing is clear. Going forward, enterprises are saying, hey, you know what? Not interested in data center management. I'm going to rent hardware from the cloud. So then the business got thinking, hey, if I can rent a machine from the cloud, can I not rent a database also from the cloud? Right? Human desires, there's no end to it. Right? Can I not rent a storage from the cloud? Can I not rent a truck from the cloud? Can I not rent a suitcase from the cloud? You think I'm kidding? I'm not. If you want to move a huge volume of data from on-prem to the cloud, AWS can actually send out a truck. Of course, this happens in the US. A truck, it's like a really gigantic truck which has lots and lots of storages. You can connect it to a data center and they will drive it back to their data center for the data migration. I'm not kidding. If the data is not that big, a suitcase, right? Probably like, maybe about 2 feet by a foot and a half or something like that, right? A little, suitcase can be shipped to you. You can pump your data in and it can be sent back to the data center for data migration. So the cloud, in terms of the definition, what people for the most part know, that definition has changed significantly. And more, the cloud services is giving what is called as managed services. These cloud providers are giving managed services. And I have given a very conservative number here, 100 plus services. When I basically go out there and pick, let's say AWS, it's about 170 plus. Google, Microsoft, almost the same. So now the business is even more excited. Oh, that's awesome. So that means you're going to take care of the database for me. Awesome. So then what do I need to do? I need to write this the application. And I will start connecting, right, all of these services on the cloud. In fact, I don't know, but I'm still going to say it. You might be surprised. You can actually get human capital from the cloud as well. So if you want somebody to do some manual work, for example, you've built a machine learning algorithm and you have an image on one hand and the finding in the other, and you want to make sure that somebody looks through it like, like this, you could do that. You could actually also get human capital. So the definition of cloud, what it used to exist in the past, honestly, has significantly changed. All right. And these set of services play a very, very vital role, right, in an enterprise's journey. So what does this mean for us? What does it mean for you? What does it mean for the entire technological fraternity? It basically means we now need to figure out ways how I can take these cloud managed services, understand the business perspective, make sure I'm doing the due diligence to figure out the right service for the right use case, customize it perhaps, as in using its APIs and customize it to my usage. I obviously can't customize the managed service given by the cloud, and then try and solve business problems. If you really look at it in this entire thought process, one thing is coming out really clear. What the cloud is basically saying, listen, all the heavy lifting that you had to do yourself, I am going to do that for you. I'm going to free up all of that time. You don't have to sit and monitor a database. You don't have to sit and monitor a network. You don't have to sit and monitor hardware utilization. You don't have to worry at 3 in the morning that, hey, my server has gone down. Now I have to rush to office to make sure my server is up and running. I got all of that. The time that you have now, build great applications for your customers. Work with the customers trying to solve real life problems. All the heavy lifting and plumbing, as they call it, right? We got it for you, right? And I'll tell you what, managed services is probably something that is skyrocketing, right? The cloud's popularity in the business. And many cloud providers are essentially saying, okay, if I don't have this service, business, you tell me what is it that you want. Many cloud providers are so customer centric. They're saying, if you want something, I'm going to give that to you. I will give you an example. Maybe about 8 months back, big data, Cassandra. I don't know if you guys have heard of it. Doesn't matter. There is a tool. By the way, if you know Netflix, you should know Cassandra. Netflix's backend is Cassandra, right? So Cassandra is a horizontally scalable distributed system. This as a service was not available in one of the cloud providers. In the last 3 months or so, it is now offered as a managed service. So now you can imagine if there is any other organization that ended up using Cassandra and had to employ specific vertical expertise to install, tune, upgrade, backup, recovery, all of those processes to set things up. Now, guess what? Those guys are now free and they can actually start working on creating a better model, ensuring that all the aspects of Cassandra in terms of modeling, etc., is taken care of. Why? Because all the administration and everything is taken care of by the cloud provider. Isn't that great for the business? I think it's awesome. If you're thinking that might mean job loss, well, I respectfully disagree. I'll tell you why not. With an example, 1980s, when there used to be these movies, okay, all of these hotshot bosses used to have, these steno, and their prime job was to take dictation. And after taking the dictation, they used to type it up in a letter, right, in the typewriter. And then they used to come back with the signature. Now, if you really look at it, does that job exist? It doesn't, isn't it? But because of the creation of Word, creation of document processing systems, don't you think multiple other opportunities have been created? So we have to look at it in perspective. So if somebody wants to do exactly the same things for a period of 50 years, well, 50 is too much. Let's say 30 years, right? We are talking IT here. Every day there is a new thing, right? 30 years, well, obviously there won't be any relevance. So I like to use this word in this context. Change is the only constant. Things are changing. New services will come. Older services will go. We have to constantly reinvent ourselves, constantly look at newer ways to deliver better applications for our customers. And I can tell you this, managed services is an ocean and it continues to grow. The set of services, probably, I'm going to give you a specific example on AWS. And I think it was around, I guess, under 100, maybe about 3 years back. Actually, it was way under 100, about 3-4 years back. Today, we are talking 170 plus. So I know for a fact in the last couple of years, some of these cloud providers have more than doubled their managed services. It's essentially making a statement, right? Which is anything related to plumbing, heavy lifting, you got the cloud to cover your back. Is cloud only for the enterprise? Well, no, cloud's for you too. And that's the great part about cloud. And I want to use this word omnipresent. So if you really look, you can use your mobile phone to switch on the geyser. You can use your mobile phone to switch on that air purifier. You can use your mobile phone to switch on the car. Your car can talk to you through a mobile phone. What's all this? And I'll tell you what, let me see if I have it or not. Look at this. It's a small Alexa that I have. Okay. What does this do? This essentially has the ability to talk to the cloud and play, let's say, my favorite Kishore Kumar songs. It can read out news for me. So if this is the case, then why can't I purchase a Raspberry Pi and I can connect it to the cloud? And at the other end, I can have the Raspberry Pi connected to a motion sensor, connected to a humidity sensor, connected to a temperature sensor, and pretty much create a home solution for me. And you know what it takes? This Pi basically, I have it at my home at the moment. This Pi has Raspbian installed in it, right? It has Python installed in it, and it is talking to the cloud. You remember we talked about function as a service? So this can actually send out a message through MQTT, and it can actually talk to a function on the cloud. Right now, what it does, nothing, because I don't have the devices right yet. So once I do get the devices, what I can do is I can have a motion sensor right here, which can send a message to the cloud. The cloud can send that message over to my mobile phone. And it basically says, somebody who was not supposed to be there is there, right? I can build this. Now you might say, well, these solutions are there in the market. I agree with that, but that I didn't build. I'm trying to basically explain that cloud is not just for the enterprise. If you are creative, the kind of tools that you are going to get from the cloud is unbelievable. Unbelievable. For example, this is again something that I have. It's a Lego Minexty, right? A small robot. You see that white little thing right in the middle? It's called as the brick. That's the intelligence. That's the heart of it. So I can actually control it from my laptop through Bluetooth. I can do that. Now imagine if I can integrate the Raspberry Pi with this, and this thing carries, let's say, a mobile phone, and there are plenty of applications that has the ability to stream video. Can I not create Curiosity rover? Well, I know Curiosity is currently on Mars, but let's assume I'm not at home, right? Through the cloud, I can make this thing go around the house with the camera on, and I can basically tell what's going on. See, these are the kind of solutions you can build as an individual. Forget about the business, right? So the cloud is not just about getting machines, storage, networking, managed services, large enterprises, deploying complex applications, worldwide production. No, it's not that. As an individual, you can do wonders, right? So that's exactly what you can work on. So these are the things I'm working on. What are you going to work on? So that's all I had for you, right? To get you an idea in terms of what cloud is and who cloud or what are the segments where cloud can help. Who are the people who can benefit from cloud? I hope you liked it. I'll take questions now.
So I'll be reading out the questions now, and you can answer them. So the first question is from Dunya, and she asks, can a cloud service provider like Sage, which is used in accounting, host the company softwares and website too? Or do we have to have two different cloud service providers for each of the softwares?
See, I'll tell you what, it depends on the strategy of that cloud provider. For example, and I want to use this term called multi-tenancy. Now, the thing is, if the software that you are talking about, right, I don't have personal experience on this, but the concept is pretty much the same. So suppose this a particular application is multi-tenant. In other words, I make one set of installation, and that set of installation can cater to multiple customers out there right, then I think you could probably get by having a single infrastructure. Otherwise, if it is not multi-tenant, there is a good chance that you may have to go in for a customer-centric, customer-specific deployment. To be honest, I did mention about that platform as a service, isn't it? I want to basically bring that flavor into your question. So some of these platform as a service providers do have a concept called as namespace. So if you build your application using these technologies, these capabilities, platforms, etc., you can basically get multi-tenancy out of the box. But of course, right, that is only for new applications. You can't expect an existing application to be completely remodeled, right, and deployed in a multi-tenant environment. I don't know if I answered your question, but I think the key here is to be, kept in mind is multi-tenancy.
Thank you, sir, for that answer. The next question is from NS Iyer, and what he asks is, how is interportability managed if one of the data centers go bust?
How is what managed?
How is the interportability managed if one of the data centers go bust?
Okay. So yeah, this is basically the concept of deploying highly resilient and fault tolerant applications. And I think this is a very important question for us to really pay attention to. And it's going to be a long answer. So I request you guys to bear with me. So if you really see, any application infrastructure has multiple layers, tiers, whatever you want to call it, doesn't really matter. So when you have an application, and I want to simplify this application and its data that it relies on, if this setup is deployed in one availability in one region, and if you lose that connectivity, you need to have another copy of it running in another region. Now, the question is, from an application server perspective, it's an easy problem to solve. Why? Because whether you use infra as a service, platform as a service, function as a service, it's code. You can deploy it here and you can deploy it here. But what about the data? And there's a big question mark around that. So many cloud providers allow you default out of the box data replication from region A to region B. Furthermore, you also have the ability to use what is called as masterless data infrastructure. In other words, you can have data nodes here, you can have data nodes here, and it is masterless. In other words, application servers from this data center, application servers from this data center can contact any one of them. So even if this entire thing does go down, it's this data center which has the full data set. Why? Because both these data centers will replicate data in real time. Now you might then ask the question, well, what about latency? So you can say that, listen, if I have an application server which is using this data center, asynchronously transfer data to here. Don't block me. You got that? So the underlying data infrastructure can seamlessly, asynchronously shift the data from one region to the other. So that now, even if the whole region collapses, you have the entire data set on the right-hand side or in the other data center. The term to be used here is also called as, well, it's an old term. I'm sure you're familiar with that. It's called active-active, master-master, or masterless, whatever you want to call it. So now the point is, the one last aspect is, okay, that's fine. So I've got my application here, I've got my application here. I get it that there is a way, right, by which I can shift the data across these data centers in real time, asynchronously. I got that. But how does the user know that this data center is down and therefore go there? There are other set of services which is called as DNS services. So some of these DNS services are extremely smart. So you can set up rules in there to say that if this data center goes down, send all the traffic to the other data center. You can set up rules. Pardon me. For example, if this particular user is coming from a specific region, you send that particular user's request to the data center which is closer to that user's region. If this is primary and if this is secondary, send every single request to the primary. If the primary collapses, send it to the secondary. You can set rules like this and combinations, including latency awareness. So once you put together all of these services, and by the way, all of this, what I just talked about, except for your application, everything can be available as a managed service from the cloud. You do not have to set up all of these. That's exactly what I'm talking about when I say heavy lifting. This is heavy lifting. This is what we had to build so carefully in the past, but not anymore, right? So all of these services, when I put together, I really truly get a global deployment, which has the ability to withstand regional outages.
Thank you, sir, for the answer. The next question is from Mudit, and he's asking how to deal with risk relating to data confidentiality, which is higher in cloud computing as compared to on-prem.
200 years ago, I want to take you back in time. 200 years ago, our forefathers, when they used to have money, remember gold coins and all of those things, what they used to do? Dig a hole and bury it there in the house only, isn't it? Today, we all take our hard earned money and we keep it in a bank. Now, after the recent changes here in India, instead of 100,000 rupees, now you get 500,000 rupees. That is the coverage you have. You can have, a million rupees in there, but if the bank tanks, you're going to get 500,000, then that's it. It doesn't really matter how much you have. You're trusting the bank with your hard earned money now, don't you? The notion of cloud being less secure is a fact. I cannot deny that. But it comes with a rider. And the rider is shared responsibilities model. Tell me one thing, when you go on vacation, oh, what would we do to go on vacation now, isn't it? Anyway, um, when you go on vacation, you lock the house. Are you saying that you're guaranteeing the security of your house? That nobody will ever break into that particular house? Really? You are doing your best to create deterrence, to basically say that I have a lock, I have a safety door, my balcony door or the patio door is closed. It has also a lock in there. I have grill in my windows to create deterrence from external unwelcome guests to get in, isn't it? But are you guaranteeing 100%? You're not. Makes sense. Same is the case with cloud security. When you talk about cloud security and data protection, you're equal party to it. If you ensure that your data, wherever you store the data, on disks, on, let's say, storage as a service, whatever it might be, has enough checks and balances, has the right policies associated with it, right, has an application which really protects that application from any and all unauthorized access, right? You have encryption in place. If you put together all of these checks and balances, you have created enough deterrence to ensure that nobody can brute force. You've ensured that your application is relatively safe. Got that? So I don't think there is any security consultant who can ever go out there and say that, listen, I will give you a cloud architecture which is 100% secure. Even your on-prem application is not 100% secure. I can guarantee that. The only application that is 100% sure is a standalone laptop, which is buried 200 feet down in a well and it is covered with concrete. Get that? So no, I know exactly what you asked, right? What I'm trying to tell you is cloud will give you the tools. If you do not use the tools well, you will have data breaches. No questions about that. I'm not going to lie to you, but that's the reality anywhere.
Thank you for your answer, sir. So the next question is from Krishnendu. So the question is, as a beginner, which cloud service provider is easier to start with?
Yeah, see, actually, it's a difficult question. It looks very simple, but I tell you what, it is a difficult question to answer for several reasons. Suppose you are a Microsoft person, you're a Microsoft developer. Maybe you can consider Microsoft Azure, although I'm not saying that Microsoft Azure promotes their programming languages, don't, right? But you might feel homely. You might feel at home that, oh yeah, these kind of things I'm familiar with, I've seen, right? Something like that. You might have that comfort factor. If you're basically coming purely from infrastructure background, then there's a good chance it won't matter, right? You can go with any one of the cloud providers. It really doesn't matter. But I'll tell you what, the main decision should be in line with what your business wants. If your business is predominantly into open source and they have built all of these bespoke applications from ground up, and at a strategic level they have a tie-up with one of the cloud providers, then there's a good chance that, you know what, they will go with that cloud provider. For example, it's a fact, it's a case study. General Electric has a partnership with AWS. So it doesn't matter, right? Whether, an application is written in Microsoft technologies or open source or anything else for that matter, it doesn't matter. Everything goes on AWS, full stop. On the other hand, there can be other companies, right? They may have chosen Microsoft Azure or even Google for that matter. I think that is what you need to look at, right? If you're in an enterprise, if the question is a personal question, that means forget about all of that, right? I am an individual. You tell me, right, what cloud I should start off with. Then my answer will be different. And the answer is, at the end of the day, listen, whatever helps you get a better job. If you are an individual, if you're asking that question, whatever makes you, helps you get a better job, helps you shine at work, right? And finally, to be honest, right, I have always selected technologies that I'm personally interested in, right? So why don't you do a dry run, a trial run on all three providers? Take a simple use case. I will grab a VM and I will deploy my application and I'll see how easy it is, right? You can create a free account in all of these, right? All the cloud providers will give you, the top three cloud providers, AWS, Microsoft, and Google, in that order. All of them will give you free accounts. Create an account, play around with it, and see how comfortable you feel. You know what? It's exactly the same as buying a vehicle. You take it for a test drive, don't you? I'm saying take the cloud out for a test drive. You will get your own answer.
Thank you, sir, for that wonderful answer. The next question is from Dinkar. And the question is, how secure is our data if we are training our data sets on Google Console or Amazon EC2?
I'm saying how secure is what?
How secure is our data if we are training the data sets on Google Console or maybe on Amazon EC2?
See, I'll tell you what, at the end of the day, all these cloud providers have something called as VPC, virtual private cloud. The whole objective of VPC, and when you are also talking about, managed services, which is available from the cloud, right? The idea is the cloud provider isolates your traffic from anyone else, right? Just one moment, my laptop is running low on battery. Okay. Right. So it basically isolates your traffic, your data, your infrastructure, your everything from everyone else. So if you're talking about security, let's break down security into multiple chunks. First is your data at transit. So that means you're sending the data over to the cloud. Well, actually, whether you send the data over to the cloud through the internet, well, there is nothing the cloud can do. There's nothing you can do, right? So you'll have to ensure that when you're shipping the data across to the cloud, make sure that the channel is encrypted, right? So VPN is an option if you're looking at from your enterprise. Once the data has landed in the cloud, and if you're saving your data set for your training data set, which could be in any format, in, let's say, storage as a service, but if you do not have the necessary barriers which I was talking about earlier, then obviously your data is not secure, right? And when you are actually talking about training a model, right, and the model is coming out of the box from the cloud provider, rest assured the cloud will do whatever it takes, right, to make sure that your data, your training the whatever you create as part of that exercise stays in your account, and it can't be taken by any other user. Having said that, there can be common platforms which can be opened to, let's say, universities, educational institutions, and things like that, where those platforms are designed for sharing. That means if somebody is basically working on some particular model and is using a particular algorithm and trying to figure out some correlations, right, and things like that, there is a good chance that those platforms will share data with others, because that's what they're designed for, collaborative learning. So if you end up using something like that, there is a good chance that somebody else might have access to the data. Right? So we'll have to keep all of these dimensions in mind by understanding the nature of that service, by understanding the nuances of that service, by understanding the features of that service. And then you'll have to say, okay, yep, that won't cut it. That one, yeah, I like that. I would rather use that because it has all these isolations in place. So data at rest and data in transit, two separate things.
Thank you, sir. The next question is from Sahil. And he says, "Hi, sir. Can you please share the depth difference between semi structured database and unstructured database in terms of their attributes?"
In terms of
Their attributes.
attributes. Okay. So when you're, actually, it's got nothing to do with cloud, but I will still answer the question. Why not? Okay. So what is structured database? Let us think of it like this. I've got a table, right? And table has columns, and each one of those columns has data types. And I store my data in this grid, isn't it? A row comprises of multiple columns. Each one of those columns has a data type, and my data, whatever I put in, has to fit into this model, right? Structured data. Unstructured data is like a document, a Word document, a PPT, right? It could be a drawing. It could be an HTML page where there is no structure. Some pages can have opening paragraph. Somebody can have a table. Anybody can have anything, and it's pretty much. So now the question is, I tell you what, this is one of my favorite subjects, to be honest. Okay. Um, you must have heard of search engines, right? Search engines. Like, of course, Google is a search engine, but that's not what I'm talking about, right? Of course, it does, much more than that. But when you're talking about search as a field of study, right, you will come to know a couple of things, very interesting things. What search does is it basically takes this unstructured data where there is nothing, it's just text. If I take a PDF document and if I extract the text content of it, that's unstructured data. There's no structure to it. You got that? So what I can do is I can put a search engine, I can make a search engine sit on top of that, and then I can search for keywords. I can also say that if I have a document, I can have metadata associated with that particular document. That can be looked at as a structured data. Are you getting this? I'll basically say it again. So you have a PDF document, right? Assume that the PDF document is a invoice, right? That invoice has obviously, some fields and all of those kind of things. That invoice is from some certain customer. That invoice belongs to so and so financial quarter. It belongs to this assessment year, etc., etc. These are fixed values. So what you could do is you could create, quote unquote, a search index, which comprises of these hard attributes, fixed attributes. And then you can say the rest of the document is free text search. And it internally creates what is called as an inverted index. I don't want to go into that. So in case of an RDBMS or a structured data set, what you would want to do is you will issue a select query. Select blah, blah, blah from certain table, comma so-and-so, where so-and-so, join, order by, and all of that. Very structured way. In case of unstructured data, you will issue a query. Can you get me all documents, if any, that contains a key which looks like this, and it also carries an attribute which looks like this. And by the way, I'm giving you two terms. These two terms should be within 10 words of each other. Are you getting the difference in data fetching? The first one is structured data fetch, structured data, RDBMS. And second is unstructured data, primarily driven and controlled by search engines. And Apache Lucene, by the way, is a very popular option.
Thank you, sir, for that answer. We'll take two more questions. One question is from Lokesh, and he asks, "Can you please tell us about vendor lock-in, while moving infrastructure from traditional data center to cloud data center?"
Right. See, to be honest, when you're doing a lift and shift, that means you are trying to create your on-prem infrastructure onto the cloud as is, without really having to, worry about setting everything up. Right. You're basically talking about a lift and shift. I don't think there is that much of a lock-in that you need to worry about. The reason, because let's take a practical example. I have an application. Forget about an application. I have a database. Let's say I have MySQL database. Okay. And it's currently running on a machine with certain specifications. If I get exactly the same machine or equivalent, pretty close to it, on the cloud, can I not have the same MySQL database running there? Can I not have exactly the same set of capabilities which that database offered on-prem on the cloud? Of course I can do that. So when you're actually taking an existing application and its infrastructure and you're going to throw it onto the cloud by recreating whatever it wants, whichever it enjoyed on-prem, I really don't think vendor lock-in is something that you need to worry about. You're probably on the left-hand side of that stack.
Thank you, sir, for that answer. The next question and the last question of the session is from Rakesh Mishra. And the question is, why do Indian financial institutions hesitate so much to go on cloud? Is it because of compliance, security, cost, or is it something else?
Ah, okay. So I think you got me there. Um, See, I have not worked in a financial institution, to be very honest with you, right? And I don't want to, give a false answer or anything like that. I really don't know the reason, right? Maybe it is true, maybe it isn't. I really don't know. But if you ask me to say that, okay, Nirmallya, I got that, right? Can you hypothesize and assume certain things and tell me if those assumptions were right, then what would be the reason? If I can basically paraphrase the question like that, then I'll answer. So let us assume that the financial institutions say, listen, we are in India and I want our servers to be physically present in India and nowhere else. Our data needs to be audited. Our audit policies basically says that the auditing firm will have to probably inspect the data, how it is being stored, how it is encrypted, and they have their own checks and balances. Maybe there are policies like that. If you look at the cloud, will you have access to their data centers? No. Does all the, well, actually now pretty much all the cloud providers have their data centers in India, right? Amazon has it, Microsoft has it, Google has it. So in the early days, not all cloud providers had their data centers in India. So that itself is a deterrent, that if my data is sitting out in some other country, right, I'm not going to take cloud computing for that matter. And finally, to be honest with you, right, it is, I think it's also fear, because at the end of the day, look what will end up happening. It's money we are talking about, isn't it? The loss of, say, a customer record which basically said, oh, the last 5 orders from this particular person is 5 kg potato, 2 kg onion, right, 10 kgs of mango. Okay, if that leaks out in the public forum, let it leak out. Who cares? But if the information which basically says person A, B, and C has this much amount of money in the bank happens to be this is the account number, that is apocalypse, isn't it? It's like the end of the world for that financial institution. So I honestly think that financial institutions are coming around. It's not they're not. There are many use cases, right? HSBC Bank is on the cloud. Then not fully, but partially. There is a bank, Monzo, Monzo, right? Monzo, whatever it is, right? That bank in UK, right, is completely on the cloud. There is a bank in Australia. There are a couple of banks in the US. They are moving their core banking applications over to the cloud. See, what happens is financial institution, because of the paranoia, and thankfully they are paranoid about our money, right? Right? It's great, right? So what is happening is as the cloud matures, right, the paranoia will reduce. People will get more and more confidence on cloud. And financial institution is right at the very end of that queue of all the domains. When I talk about domains, I'm talking about telco, FMCG, travel and luxury, like whatever it is. All of these are domains. Financial domain happens to be the last one. And actually, to be honest with you, I don't mind that. So if the bank is not comfortable, chances are they will mess it up. I'm not saying that the cloud is insecure. I'm saying if the financial institution is not confident, chances are they will mess it up. It's as simple as that. Look, right, I have not ridden a bike in 29, 30, no, it's more than that. Yeah, I think about 30 years. Right, somebody if tells me that, hey, you know what, with all of this situation, I'll give you a bike, you go. I'm not confident, right? I have not ridden a bike for so long. Will I mess it up? There's a high possibility I will. But does that make the bike a bad choice? No, isn't it? So for somebody, let's say, for example, a younger person who is basically used to riding bikes around, right? That person will say, yeah, bring it on. That's the difference.
Thank you, sir, for that answer. With this, we come to the end of the session, and I request sir to share any advice or any pointer that might be useful for anybody who's just starting out in the fields of cloud computing.
Right. See, I'll tell you what. As simple as the word sounds, just one thing, right? Cloud. It's a massive ocean. So I suggest if some of you are looking to, come on board, and if you are basically, okay, what happened here? Sorry. All right. If you are basically thinking to get started with cloud, then I think what you need to look at is to figure out what makes you most comfortable in terms of taking the route of exploring cloud with respect to taking an existing application and deploying something, whether it means that let me build an application natively on the cloud and see how that goes, or you are looking into the operations side of things. For example, if you're from a strong operations background, you might say, let me figure out what it takes to manage applications and infrastructure on the cloud. It kind of depends on what your expertise is. I can tell you this from my personal experience, right? I've been a developer all my life and I continue to write code in Python and Java. When I started with cloud in 2008, 2009, when I started exploring this, right, I basically looked at an option which allowed me to write code and deploy code because that's my comfort zone, right? I did not go in for anything else. The reason because, and it's a fact, that the initial impression has a lasting effect. So the last thing you want to do to yourself is to have that, not so pleasant initial, experience with the cloud. So figure out who you are, figure out what is the equivalent offering from the cloud, and explore from there. I think that's the straight, from the heart advice I can give you.
With this, we are about to just end the session, sir. We thank you for the time that you gave, and I am very sure that our learners will be very much benefited by the session today. Uh, and with this, we end the session. But before this, I would strongly urge all the learners to go and check out Great Learning Academy. The link of the website you can find in the description box, and there you'll find courses on cloud and a myriad of other courses for the technical knowledge and on the technical knowledge, and you can enroll the courses and you can get your free certificates. So please go there, register, and start your learning of the skills that are greatly required in the industry today. Thank you for joining the session, and thank you, sir, again for this wonderful session that you
Thank you
created.
for having me.
Bye.